Hello, discrete math fans. When we add two numbers, we just write a plus b. What do we do when we want to add a bunch of numbers? Then we're going to use sigma notation. So what we like to do is come up with a similar notation when we want to take the union or the intersection of many sets, not just a pair of sets. So to lead up to that, let's talk about indexed collections of sets. So that's a collection of sets, each of which has an index to identify it with. So for example, you can talk about A1, A2, A3, and so on. We'll call that an indexed collection of sets. The index set is n. So the index set just labels the sets. And they're all different sets. So with that in mind, now we're going to define the union and intersection of indexed collections of sets. We're going to give two definitions for each. One works for a finite collection of sets, the other for an infinite collection. All right, so the definition looks like this. If you want to take an infinite collection of sets, A1, A2, A3, each of which is a subset of a universal set U, then we can create finite unions like this and finite intersections like this. A finite union is where we're going to take the collection of all x's that are in the universal set, for which x is an element of a sub j for at least one j. And the same thing for the intersection, except now the x's have to be in all of the a sub j's. The definitions are essentially the same for the infinite union and the infinite intersection. The difference, of course, is that where are we taking the indexing? Now they're coming from all natural numbers. As an alternative for the finite unions and finite intersections, we could just write them like this, which is the exact same thing that you would do when you do addition of a finite number of integers or real numbers. You could just list them all, and the same thing works if you want to do a finite union. You can't really do this with an infinite union because you can't write forever. Okay, that's all for now.